So here's our first example question. IQ has a normal distribution in a sample of students. Find the 95% confidence interval for the mean IQ of the student population based on a sample of 25 students with an average IQ of 98 and standard deviation of 6.52 points. I've given you the formula. I've given you the z-score that corresponds to each of the confidence intervals. Go ahead and see if you can work through this problem. Okay, so let's see if you got the right answer. So let's see what we got. So we're going to go ahead and plug in our numbers that's given to us into our formula. So we see that out of a sample of 25 students, so we know that our n is 25. That sample of 25 students has an average IQ of 98. So this average IQ of 98 is our sample mean. So x bar. We see our standard deviation is 6.52. And the last piece is our z-score. So I wanted you to find the 95% confidence interval. Well, we know that the 95% confidence interval corresponds to a z-score of 1.96. So go ahead and enter all those numbers into the formula. Here we go. As we work through that calculation, let's go ahead and work through our standard error of the mean. We get 1.304. Multiplying our standard error of the mean with our z-score, we have 2.556. Now we can go ahead and find our lower limit and our upper limit. So our lower limit, we take 2.556, subtract that from our mean, gives us 95.44. And our upper limit, we add 2.556 to our mean, which gives us 100.56. This is not our final answer. The final answer, whenever we're working with confidence intervals, must always be written as such. 95% confidence interval is 95.44, 100.56, with our upper and lower limit surrounded by parentheses. And we always list the lower limit first and always list the upper limit second and separated by a comma. So always write out our confidence interval by stating what confidence interval it is, what percentage. And then we state our lower limit, comma, upper limit, enclosed by parentheses. And the way that we interpret our answer is that we are 95% sure the true population of students' average IQ scores falls between 95.44 and 100.56. Again, we don't know all the IQ levels of every single student in the US. So in this sample of 25 people, we essentially found an average of 98. And because we don't really know what the population parameter is, we're going to guess with 95% certainty that the true population average IQ falls between 95.44 and 100.56. We just did our first inferential statistic, where we inferred from a sample of 25 to a population, saying that we think between these two numbers of 95.44 and 100.56, with 95% certainty, the average IQ of students falls between here. Now I want to take a moment before we continue on. Take a look here. What do you think this is? This number, 2.556. I'll give you a clue. Take a look at the plus or minus in front of it. Well, this is your margin of error. So when we're calculating and multiplying our z-score, which is based upon the percent confidence interval we want, times our standard error of the mean, we're calculating the margin of error. Okay, so now that we know how to calculate a confidence interval using this formula and looking at our 95% confidence, go ahead and try to calculate the 90th percent confidence interval and the 99% confidence interval and see what you get. Okay, so hopefully you work through calculating the 90th percent confidence interval and the 99th percent confidence interval. So let's take a look. For your 90th percent confidence interval, you should have got 95.85 as your lower limit, and your upper limit 100.15. And if you just look at your calculations, you'll see that your margin of error plus or minus 2.15. And if you have your 99% confidence interval, you'll see that your lower limit is 94.64 and your upper limit is 101.36 with a margin of error of plus or minus 3.36. So given that, take a look and compare the 90th to the 95th to the 99% confidence interval and look at what's happening to your margin of error and look what's happening to your lower and upper limits and how it's getting wider and wider and wider. Alright, our second calculation. IQ has a normal distribution in a sample of students. Based upon a sample of students whose mean IQ score was 105 with a margin of error of 3, would you estimate that IQ in the student population is greater than 100? And this is a yes or no question. But in order for you to answer this yes or no question of whether or not you estimate that the IQ in the student population is greater than 100, you have to work through it, show me your work, in order for you to justify your answer. So go ahead and see if you can work through this and see if you can come up with an answer. Alright, so let's see how you did and see if you got this. So we see that we're given an average IQ score of 105. So we have our mean. We have a margin of error of 3. So given that, do we need to use this formula? We don't. Well, we know that we have the margin of error, which is 3, and we just talked about how plus or minus z times the standard error of the mean gives us our margin of error. We can just go ahead and figure out what our upper and lower limits are. So we see our lower limit is 102, our upper limit is 108. So knowing that our confidence interval consists of 102 and 108, well, yes, we can estimate that the IQ in the student population is greater than 100 because the confidence interval of 102 and 108 does not contain that 100. The confidence interval does not have the 100 in it because the numbers are bigger than 100. So yes, we would estimate that the IQ in the student population is greater than 100. If our confidence interval contained that 100, if our lower limit, let's say, was 90, then we would say that no, we would not estimate that the IQ in the student population is greater than 100 because we're saying that it could be as low as 90. Well, in this case, we see that we're confident that the student population parameter for IQ is as low as 102. So yeah, we can be confident in saying that it's greater than 100. Okay, calculation number 3. So IQ has a normal distribution in a sample of students. The 95% confidence interval is 100 and 105. Find the point estimate and find the margin of error. Go ahead and see if you can work through these two problems. Okay, so let's see if you were able to work through finding the point estimate and the margin of error. So if we have the 95th percent confidence interval with the lower limit of 100 and the upper limit of 105, the point estimate is where relative to the upper and lower limit? It's right in between, right? So knowing that, we just go ahead and find the average. Find the position in the middle, so if we add the 2 up and divide by 2, we will get the point estimate, which in this case is 102.5. So in this sample of students, the average IQ level is 102.5. Now that we know the point estimate, and we know what the upper and lower limit is, what's the margin of error? The margin of error is simply the distance between the point estimate and the lower limit, or the point estimate and the upper limit. So we can simply find that distance. And since we know the point estimate, now we can just do the upper limit minus the point estimate, or the point estimate minus the lower limit. And we see we get the exact same answer.